Hi, my name is Håkan Silvernagel and I want to welcome you to the Norwegian .NET user group Oslo. We are part of the .NET Foundation and we are an independent user group with focus on .NET. We are by developers for developers, and we focus on talks where presenters have practical experience of the things that they're talking about. If you want to reach us, you can reach us on our social media handles that you can see here on this slide, and we're always interested in people who want to present. We'd also like to take this opportunity to thank our sponsors, so they are the ones who make it possible for us to arrange these meetups on a regular interval. And we are the organizers of the Norwegian.net user group, so please contact us if you have any questions or comments. Now I would like to mention the Global Azure 2022. So that's a virtual conference taking place from May 5 to May 7th. And here in Norway, we are representing Norway through Global Azure Norway. And our CFP is currently open, and you can reach it by scanning the QR code that you can see here on this slide. Our user group's partnership with Microsoft makes it possible to give away a Microsoft Azure branded backpack for the best technical question. Now this is only open for the people who are attending the in-person event. But everyone can learn more about event sourcing by following the QR code here and learn more about it in the Azure Architecture Center. Now the agenda for tonight is we will have two parts here. First is the event sourcing, the theory, and then we'll have a small break, and then we have the event sourcing in practice. And with that said, I will leave the floor in the presentation to Einar Ingebrigtsen, who will present event sourcing, why, when, and how. Now the stage is yours, Einar.
So, welcome, and thank you guys for having me as the first in-person in 2 years. That's pretty awesome. And thank you everyone for coming. That's even more awesome. Having online meetups is not that cool because it's kind of nice to almost touch people, right? So, without further ado, let's talk about event sourcing, if I can get this to work. So, today I'm going to talk, well, the topic says what it says, why, when, and how. I'm also going to talk about what. So, there's more today. So, but before we actually go there, I want to set the stage a little bit. So, we're coming, so if you look back 40, 50 years, this is kind of where we're coming from, right? And we've progressed from this to this, right? This is kind of the evolution of computing going on. And with this evolution, well, we're no longer confined to small computers. We're no longer confined to small mainframes or whatever. We have vast computing power. But it comes at a sort of a price. It comes with some limits and also new opportunities. So if you look at it, we've actually plateaued a little bit. If you look at the last 10, 15 years, we've actually reached a point where CPUs can't get much faster, right? So Moore's law isn't delivering on the promise it has been doing since the 60s. So what we're actually seeing is that, okay, we are now seeing hard limits on what's actually physically possible. We've reached those hard physical limitations. But we're also seeing at the same time that more and more, well, users are expecting more. More and more companies are becoming digital. The society in general is becoming more digital. And also the expectations from our users, they are now growing up with the Facebooks of the world, right? They're growing up in an app economy. They're growing up with things that demand much more of our systems. So that means we need to start thinking about how we actually do that, because if you look back into the 40, 50 years of evolution in hardware, we haven't progressed that much in software. We're doing a lot of the same things we actually did in the 70s. We're still doing SQL, for crying out loud. So SQL came about with a constraint of the time in the 70s, which were memory and CPU. We don't have those constraints anymore. So we need to start thinking about different ways of doing these things. And if you look at the kind of the limitations of the Moore's law limitation here, And what that brings to the table is actually looking into the data centers. We see that everything is changing, right? Our cloud environment, first of all, the cloud environment is super flaky. It's there or it's not. And it's intermittently there, right? And you have to kind of design for that. You have to start thinking differently about how you actually design your solutions because resources might not be there, right? So it's a flaky environment. And we have to build for, well, more CPU cores. We don't have one core. So that's when we see things like async await come along, right? Because we need a new programming model for that. We also see a lot more where we're spreading out. We're distributing our systems across different virtual machines or containers and kind of doing what we can to meet the demands, right? So distributed, and with that comes also the idea of, well, our solutions, our systems that we're building have to be very resilient. And they have to be online close to 100%, right? So that means we're scaling out across multiple data centers, maybe even across multiple different cloud vendors. And this is really complex environment to be in, right? And not to mention all the devices that are connecting to this. And of course, we have the nice little thing called compliance, GDPR and things like that on top of all that. So this is a lot of stuff that we as developers have to take into consideration, building systems, modern day systems today. But there are some opportunities in this. So if you look at, well, obviously, with the limitations that I just mentioned, we should be breaking up our systems into smaller pieces. That just makes kind of sense. Instead of having these monolithic systems, we should be starting to break it up. Okay, we've heard microservices for quite a while now. We are also seeing the advent of kind of serverless and that taking on, right, with functions or lambdas or whatever. But there's also an opportunity to leverage much more off-the-shelf stuff in this space as well. Because obviously, with all the demand of our software, it becomes hard to build software, and it takes a long time to build complex systems. So instead of having to build everything yourself, maybe you can leverage something off the shelf, right, and bring something already existing into the table. So, and we need to start thinking about like favoring the parallelism, right? And that's where kind of async await comes in a little bit for developers at the lower level. But we really need to think in these terms instead of thinking sequential. Because sequential will be slow. If we have a lot of tasks to do, it will be slower than doing it all in parallel. And that also puts a bit of a pressure for us on how we develop our systems. So another thing, and I know a lot of people don't like the last sentence there, like the no code, low code, but it is an opportunity. It is a possibility to take systems that aren't, or is possible to do in low code or no code even, to actually do that, right? And start focusing your effort on the things that actually matters the most, right? So with this, of course, we can become event-driven. That's an opportunity, because if we're breaking our systems apart, how do we bring them back together? And we've been doing this with APIs for quite a while, but there's some constraints with doing APIs as well. So bringing in event-driven, that's a way for us to actually decouple in a different way. So what are these events I speak of? Well, they can be a lot of things. And I think that's the biggest issue, really. Because when we start talking about things, so first of all, there will be just as many answers to a problem as there are developers in a room. +1. Yeah, +1, exactly. N+1, of course, always. So that, with terminology, that's the same thing, right? So what is an event, really? So if you look at the kind of CPU level, we talk about IRQs, interrupts. That's certainly an event. That's something that actually the CPU triggers. So someone talk about that. If you look at like the operating system, they're dispatching events, and I'm dating myself again because that's C++, Win32 stuff. So it will send out messages or events, right, saying, okay, this happened. So that's the type of event we talk about. In the DOM, we obviously have also events. We have mouse move stuff there. We have, we can add event listeners and add events, custom events even, right? So that's a type of event we talk about. C# has a native keyword for event, which has another meaning, and you can use it for anything. And anyone has done, like WinForms, WPF, are pretty much familiar with this as a way to actually know when things happen. Or you could do IoT, which is not an event. And Jakob will back me up on this. Yes. That's time series measurements. That's something completely different. But we bring all these things into the mix of events. And it's certainly not ubiquitous. It is not a ubiquitous meaning. So what I'm going to talk about today is domain events, primarily. So those, that's events that actually has a meaning in your domain. So it has a meaningful name. You certainly give it a name, so something has happened in your domain. It represents a state change in your system. And you typically model them very small and only holds the property that actually is related to the change you want to represent in the system. And this is, by the way, from anyone read the Blue Book, the dreaded Blue Book? Couple? Yes, yes, yes. And it is dreaded. So most people fall asleep in the foreword. So, but it is a good book, actually. But one of the things that Eric Evans is talking about is actually domain events. And it's very important. It's for anyone building line of business systems, this is very important aspect when we talk about event-driven and event sourcing today. So what is it not? It's definitely not a CRUD event. And I've seen this many a times because that's what we're used to. We're used to building CRUD systems. So we tend to create these fat employee updated events with everything on them. And that's not the point of these types of events. We're trying to capture what has actually changed, like an address changed on a person, and maybe even the intent of why. Why did it change? Well, the person moved. So we try really to capture specifics in the domain. So we're not trying to do these CRUD events where it's employee updated event, employee deleted event, employee blah, created event. And it's certainly not your average IoT type of event either. So it's not a, well, the temperature value has, well, not even changed, it's just a measurement, right? So it's 22, 22, 22, 23, 23. That's not what we're looking for in domain events. So fast forward to event sourcing. So that was kind of just getting started. So event sourcing, and I'm going to talk very specifically about event sourcing with a backed event store. So what does that bring to the table? So if you look at our traditional way of looking at data today, if you look at databases, most databases today is basically just looking at the effect. So we're looking at the current state. So the current state is, well, I need an umbrella, but you don't know why. Yeah, sure, you can look into logs. You can even go to the database log and see what kind of state changes actually happened if you want to, but you will not really capture why. Why did I need an umbrella? And that's where kind of event sourcing comes in and says, well, it started to rain. So we're looking for the cause, right? We're really trying to capture the cause and model the causes rather than the effect. And you can do this if you look at like a traditional, like a banking system. It's always fun to stand on stage and come up with samples that are easy enough or hard enough. And well, this is a bank for today, right? So what we do is, let's say a bank account is opened, or maybe even more specific, a debit bank account open could be an event. So we actually go and create that event. We create that type, that class or record in C# and name it so, and put the properties that we really need on it. So anything that happens to that account will now just be another event. We go further and we see, okay, we want to deposit some money to this account, so we create another event type, which is called deposit performed, and we capture what we need, well, the amount for that, and we can withdraw from this account, and we capture that event by doing so, and we might even close down the event, Ask Putin. He knows a lot about this these days. So that's a way of actually modeling events, right? And I'll get into the depths after the pause, and we'll, after the break, we'll see exactly how this is done. But if you look at this and we say, as I mentioned, we want to store these because we are sourcing the events. We're actually telling the system, this is now our source of truth. The database is no longer the source of truth at all. We need a different database. We need something that actually holds these events. And that's called an event store. So we store all of these events as they happen inside a new type of database, the event store. And as you probably are now thinking, it's like, isn't that going to be slow when I want to just know how much money I have on my bank account? Because there's going to be thousands of transactions. Well, what you actually do is you optimize this because the current state changes all the time. And what we can do then is actually project from what's going on with observers that is actually observing these events and projecting down to something that represents the current state of the system. So we project down to read models, something that we can use for reading. And the beauty about this is that we can actually now optimize how we actually store these. We can even store them in different technologies. We can optimize for different purposes, and different aspects of your system can use different technologies, which is kind of a beauty because the source of truth is now the event store. So that is all well and fine. So what happens when we want to go between systems? Well, we need to have something to define what actually is the contract between the systems. As you would do with integration today with APIs, you also need to think about how do I actually integrate different microservices or different parts of your system, different modules of your system, and create these events that, well, they might be slightly different because you don't want to go into a place where you actually are kind of exposing your internals to all other systems. You actually want to have a kind of stable contract for the outgoing part. So you create these other event types. Some people actually call it integration events. So if you go to that link actually for Microsoft, for the patterns and practices, they talk about this as integration events. So they look a little bit differently, and there are reasons for that. There's a concept called idempotency, which is all about how can we guarantee state when we actually start rerunning these events. And when you're talking about doing that to a third party, well, that becomes a lot harder. And I'll get back to the details about that. So, as I said, this is your public API, so you need to think about how do I actually version these? How do I version this type of API? Well, we're used to being versioning kind of APIs, REST APIs. How do we do this? And we don't necessarily need to have the same type of retention. So that means when I said the event store is your source of truth, that means we're actually storing, appending to that event store all the time. We're never deleting, actually. But we don't need to have that same mechanism for things going out publicly. We don't need to have the same kind of track for everything going outside. We can actually say, well, the last of an instance. We don't necessarily need all the instances of an event when it changes. So with this picture, we now basically have an outbox. So we create these specialized public events or integration events that we put into the outbox, and other, let's say, other microservices can actually now subscribe to these, and you would have one inbox per source outbox, right? So you're basically looking at capturing all the events that you're interested in from other microservices and keeping them in your own inbox. And that helps with your decoupling. So one of the promises of this is actually the whole decoupling thing. So another topic often associated with event sourcing is something called CQRS, Command Query Responsibility Segregation. rolls right off the tongue, right? It's so obvious. But it's really all about just separating your reads from your writes and formalizing that into pipelines. So you don't necessarily need to do this, but it kind of falls natural into it with this type of architecture. So think of it as, so if you look at these commands, that's actually capturing what you want to do to the system. So that can actually be even just a web API controller. So you have a controller action, you have a REST API that you're exposing to the world, typically your front end, maybe, that you're actually, I want to do this. So that can be a command, right, going in. And what you do with that is you pass it on to domain logic, and the domain logic is now responsible for, well, creating events. And that's kind of the difference here. Instead of going directly to the database and saying, hey, I want to update that in that field, you now are producing events. And these get stored into the event store. And from that, we can now project them to read models into a different database, if you will. And that can be a completely different type of, and multiple types of databases, actually on the receiving end of a projection. And you feed that back on the read side, right, all the way up. And that's kind of the closed loop of CQRS. That's a simplified version. Of course, this is a huge topic on its own, so I'm just going to touch on it a little bit, but you'll see it after the break a little bit in action, how it actually looks like. So another part of this is also the kind of if this then that scenario. So whenever something happens in your system, you can start doing things. You can start performing actions and pretty much, or reactions to it, reaction to something that happened in your system. And if you look at the IoT scenario, rather than looking at the IoT measurements as events, what you're really trying to do is to understand the IoT streams, if you will, and see meaningful things in it, and then create domain events, really, from that. So it's not that interesting in the domain to actually look at the temperature going up and down all the time, but it's very interesting to see when the temperature changes dramatically. Why did that happen? And maybe you have a second sensor that actually can tell you, well, the window was open, right? Someone opened the window, and that makes sense. Now you can create an event that actually captures that and actually pushes that instead. And that's a great candidate for machine learning, right? To actually use machine learning for these reactions that actually understands the system, looks at it, and translates that into domain events. Right. So what are the promises of event sourcing? There are some promises. Yes. Well, if you look at it, as I said, the truth in the system is really in the event store. So that is your current state, and we can do projections from this. So we can now become truly polyglot persistent, meaning that I can actually within one, so let's take one microservice, I can be using a bunch of different storage mechanisms for different features. So like a search index would be great for doing what I need to do for searching. While when I want to do relational stuff for reporting, I can still do that. Right? I can use the same events and actually just project down to these different things. I can project down to a Mongo for that purpose. I can push something onto Redis. I can even push all the way down to something like Power BI all the way, right? And be reactive instead of having to pull, right? So that's some of the opportunities here, meaning that we can actually use the right technology for the job all the time. So we can optimize our systems. Obviously, you can't be afraid of duplicates. If that is a problem for you, stay the fuck away. So that's just the nature of these things. You really can't be afraid of duplicates because it's built for this. And thank God for big data, because hard drives are super cheap now. So they did something good. And one of the things that we really get with this is the ability to actually replay our system. So replay when, for instance, we want to project differently, but we can also replay partially. We can stop at any time. We can actually start at the beginning, and we can start analyzing what's really going on in our system and actually almost scroll through our system historically. That's one of the great things about these things. So replay is really your friend. And of course, you need tooling for this, obviously, and we'll get a little bit back to that. So I've been standing over there for a while. I'm going to change. That's a light bulb. So I talked about decoupling, right? So breaking up your systems into these more digestible pieces. And that actually makes a lot of sense. So not just from a technical perspective, but also if you just think about keeping things in your head. So problems shouldn't be bigger than what you can keep in your head. So that's an opportunity that we should be thinking about these things and actually make more maintainable systems, right? So that, if you break things up into smaller pieces, that also kind of can give you an improved velocity. That's from my experience at least, is that, well, the problem is digestible. I can change it. I can do things to it much more easily than a larger system. And one of the things that we see today, so there's this hunger today for delivering fast. We can discuss that, we can debate it, but there is this hunger. And especially in the startup scene, it's like, oh yeah, we have to deliver, we have to do the MVP or even the most lovable product and blah, 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 get it out there. But the thing is that sometimes it doesn't pan out. It's actually crap. So it's great to actually be able to then say, okay, that part of the system, we can just pull the plug on it. Because if we are talking about like autonomous microservices that are totally, well, they have a copy of the events they needed, we can take out the parts that didn't work and say, oh, screw it. Let's do something else. That didn't work. So how hard can this all be? It's super easy. My work here is done. So, no. So I've been doing this for a while now, so on and off for 10 years. It is hard. Mostly because there aren't that many tools out there, really. And that's hard. So you kind of have to make the tools yourself. I love that, by the way. So that's not a problem necessarily. But the thing is that there aren't that many references either. So when you stumble upon a problem, you might be the first one to actually stumble upon it, which is kind of sucks. And you end up faking it till you make it, right? So there are some things to consider. So questions you have to kind of think about, like consistency. Well, I talked about kind of a very decoupled scenario, but consistency matters. So when I want to do like a change to the system, you might want to have a rule that says, well, that's not allowed. That becomes a big problem if it's eventual consistent, right? So when you don't have consistency. So there's part of your system, the right side typically needs a strong, consistent model. You need to be able to actually answer that question, can I do this? And you cannot rely on some eventual consistent model to actually do that. So the read side of this is by nature of this model, eventual consistent. So that's obviously something you cannot really rely on. Ask us how we know. Been there and done that. You get into trouble. So it's not your average asset, right? And if you look at it, UI becomes a bit of an issue as well, because now you're having a very different consistency model. So how do you actually get a UI to work with these things? These are questions to ask, and maybe there are some answers. Maybe there are some ways of doing this. First of all, you have to embrace eventual consistency. You have to really, really embrace it and understand it, and just build it all the way through your system and really It's not optional. And I would argue we already do this, and we've already done this, and we've already been doing this for decades. We've just been pretending that we haven't, because things haven't really been all that consistent. So just embrace it, bring it into your system as a first-class citizen, and design for this all the way from the front end. So for instance, one of the problems with the front end is that it doesn't really know when it's done. When is the state ready? Well, in the back end, we do know. We know when we have projected. So we can let the UI know at that point. We now have the technologies to do this on web, for instance, with WebSocket, or other things like HTTP2, gRPC, and things like this. We can actually start pushing things to the front end when they're ready, rather than actually waiting, right? And if you're using, well, most databases today actually support the notion of watching. So you can start a watch on a query, a specific query. The user comes in and looks at the data, and you can start a watch, like a MongoDB have watch, even SQL Server have SQL dependency, and things like this, where you can actually look at it and be notified when data changes, and then push the result to the client. Or even just signal the client to say, well, things have changed. Go get your data. So that's one way of dealing with this kind of top-down and just thinking about that problem and actually doing that. The benefit of that is that you get a better user experience, right? So thinking about this and doing this can give you new opportunities. So I mentioned the concept of idempotency. So now we have events being the source of truth, and we're saying that replay is your friend. How can we guarantee the same result every time we replay the events? How can we be sure that we get to the same state every time in an evolving system, not just a demo, but a system that actually changes, where the shape of events change, new events come and go, you might be integrating with others. How do you actually do that? That's super important, because otherwise this whole model won't work. If we can't replay and give you the same result every time, that will just not work at all. So order of the events can matter, but there are ways of going about it where it doesn't really matter that much. And it also is a bit of a consultancy answer to the order. It depends on the use case, right? So for the underlying store, there are some guarantees you need to have, like a unique incremental something, some key that actually guarantees you that order. So you need to be able to guarantee the order of things when you're inserting into that data store. Your observers need to be able to, well, they need to be isolated. So they cannot rely on other observers. So remember I said that whole thing about rules, for instance, or things not being, you cannot rely on some state from something else. That is for the observers as well. You should not be relying on state from another observer, not even a projected materialized state. You should treat your observers as complete isolated entities, and they should live on their own. The moment you go down the path of actually making them dependent on something else, you get in a little bit of a problem, because we want to be able to actually replay these as fast as we can, right? So we want to parallelize things. But you cannot really parallelize things when you have this dependency graph, because then that needs to be done before that, and so forth. So you're creating a tension in your system that you really don't want to have. So I talked about event evolution because real systems change. So in a traditional system, we change our database, our schemas, our documents, how they actually look like all the time. This is true for events as well. Your system evolves. So your events change, how they look like. The name of the events might change because, well, we didn't capture the domain correctly. It might be different. So we need to be able to capture it differently and change it. New properties are added, removed. Maybe you even totally discard an event and create new events. Maybe you want to split up an event from one event to two events because that makes sense in your domain. All of these things are evolutions in your system that you actually really need to think about when using event sourcing. Because that's, of course, this is a problem you won't see before you're in production. So if you haven't thought about that before production, you're going to be stressed out when the first user says, that's not right. So you need to think about these things. And you also might want to be able to roll back your system, which is very common today. You roll something out and there's flaws in it. How many here create bugs? Never. Yeah, exactly. So you want to be able to roll back. And that's also kind of, well, you need to think about evolution then as well. Because if we are now changing our events and migrating these events or changing them, how do we roll back those changes? Short answer is you don't. Oh, sorry. So there are different strategies to this. So if you look at kind of the simple scenario is, okay, I'm adding properties to an event. That's pretty simple. Because now we can actually just have a default value for those new properties. So whenever a new, well, something new in your system start using these properties, well, there's a default value for the old ones. So that's okay. That's fine. So that's kind of the optimistic way. And you can go the other way around as well and take away properties because, well, serializers can just ignore it and just say, it's a property I don't know, screw it. So that's kind of the optimistic approach, right? But what you should be doing is really take all the different generations or the different versions of these events as they evolve. You should capture them. You should have like a schema store where you hold these. And you should also have now migrations doing upcasting and downcasting of these different events. To be able to support what I just said about the rollback is one thing, but what if you also, well, want to support, your event store is just being appended to, and you really want to be able to support up and down in your system as well, just internally to your system. Not to mention the fact that you're actually probably also looking at this as a versioning strategy for your public events when you're talking to external systems as well, because you want to be able to treat every microservice autonomously and in isolation. So a good way would be to actually migrate by doing upcasting and downcasting between the different microservices as well. So you can do this work once. And I know this sounds a lot, like a lot of work, but we already do this because we do migration scripts for databases, right? But we, instead of doing it for the entire schema, we do it for very small parts of the system when they change, right? So we do this all the time. That's part of the evolution. And what we've been seeing throughout the years is that for the most part, changes are actually in your domain, and it's actually more of new knowledge. So you're adding more event types rather than changing existing. So this might not actually be something that you do all the time. Depends on how wrong you were in the beginning, of course. And of course, we're never wrong, so we have all, well, you have the recipe at the beginning of the project, and it's all right. So compliance. Let's not talk about that. Let's go back here. I guess we have to think about this as well. So how do we actually deal with compliance on GDPR and personal information? It is a tough problem to actually deal with, but it can be solved quite elegantly if you want to. So we want to be able to track information. So some systems actually, well, you have to actually let the user see what you're tracking for them as well. They need to be able to see that. And they need to be able to go in and say, hey, delete me. So how do you do that in an append-only kind of scenario? How do you do, well, delete data that you're not supposed to be deleting? Well, you don't. Maybe. There are some options. So if you read the GDPR stuff, there are some kind of guidelines for you. So one of the things that I keep talking about is kind of tokenization. Right? So use tokens, basically as a pointer, if you will, a link, a reference to something, to the data, the PII actually being separated out into different storage and sitting here. So that we can go and delete that PII if we want to, but still keep the pointer, but the pointer now is invalid and doesn't give us anything when we try looking it up, right? So the data is gone. That's one way of doing it. Another way would be to encrypt it and just keep it on the event, but encrypted, but not with a one key to rule them all, but actually a key per person. So you keep kind of a key store containing a personal key for every person in the system that you use for encrypting their data. What you can then do is actually go, instead of deleting the data, is deleting the key. And say, just revoke that key, and all of a sudden that data is completely useless. You cannot actually look into it. There is an aspect of doing this which is also on the security side. So, okay, have you looked at the Shrem 2 thing, the whole cloud stuff? You know? Yeah, I'm just trying to remember. No. So basically what it's boiling down to is saying that US can always get hold of our data. Right? So that's the conclusion of that trial. So they have the rights to go in and look at the data in their cloud. Well, the US government can go and say, yeah, I want to look at that. And if you're really afraid of that, encryption would be good for that. As long as, and there's the important piece, you keep the keys in a different cloud or somewhere else on premise, right? Because if you keep the key in the same cloud vendor or in the same data center, you're basically, you might as well just forget about it. Don't encrypt it. So, but from a general security perspective, encrypting it from anyone else could make sense, right? And I've tried reading that conclusion from the Norwegian government on this, and it's really not a conclusion. They're basically saying, we give up. We don't know. You figure it out. So it is a tough problem. But what we've concluded with is actually doing the encryption. So encryption is what we're going with, and doing that on a personal level, in addition to actually encrypting at rest with a key for the database as well. So we're double encrypted. So that should be good enough. Yes, I know Jakob, who's sitting there, he's smiling. Laughing inside him. He loves encryption. So, one thing that is also important, so when you typically store these events, you store a lot of metadata with them, because one of the promises that I didn't mention is that having an event store is actually a perfect audit trail. Not only does it keep all the changes, but it says exactly what changed, and you typically want to capture when it changed and maybe even who changed it. Problem is, when you capture who changed it, that could also be PII. So especially if you're using something like claims and you're just storing emails or something like that, that all of a sudden becomes PII. So you need to now do something about that as well. So that's where what we've chosen is do a token. So that's a good. That's just basically, okay, someone changed, we will look into this other place for that. That way we can actually delete that other place. So we're doing the tokenization for that part. So what about the systems that aren't event sourced? Chances are you're going to be integrated with non-event sourced systems. So how do you actually go and deal with that? Because let's face it, you internally to a microservice at least, it's not a good idea to mix models. So have source of truth be This is the event source. This is coming from there. This is coming from there. You basically want internal to your microservice or your system use one model. So if you've chosen event sourcing, you should go all in for that microservice. I'm not saying you should do it for the entire system, but for a particular microservice, that's one of the options you could be doing, right? So that means we should be converting what they're saying to us or what we're getting from them into events. And this is a model, so this is actually a little bit of a closed loop. So we go get data from like an API or a database or something. And what we basically want to do is we want to compare the changes to what we have. But what we have is not their data. What we have is a projected version of the events we're interested in to compare with. So it's actually a little bit of a, it's, what do you say? It's, yeah. It's a bit of a mindfuck, yeah. Because you actually have to have the events to be able to compare changes, to produce events. So that, but it makes sense. So the first time this happens, of course, you don't have any events. So there's going to be a lot of changes. And that's fine. Next time, though, you have all the events. And you can actually now materialize into that model that we want to compare with and start producing new changes. And chances are there's no changes, right? So that's one strategy for doing this type of thing. So over the years, there's been a lot of learnings going into this. So I'm going to just go through some of them. Immutability. I've been saying, well, you should be append only. But it's not blockchain. This is not blockchain. Okay, it has some resemblance. Please, it's not blockchain. It's just another way of storing data. So we can decide to change things. So I'm not saying willy-nilly go in and actually just update all events, but be structured about it. So think about your changes and what are the things that typically change in your system. And I'm mentioning migrations is one thing that changes. Your system is actually evolving. You might have the need to do compensations. That's a change because, well, you entered the wrong data. So you might want to be able to do that. You might have data that you're not supposed to have. Like, for instance, medical records. So let's say you're a famous person and all of a sudden you've been given a wrong diagnosis. And you don't want the public to know. You don't want to have that on Dagbladet. This guy, blah, right? So you want to be able to actually redact that information. Another thing is that this is going to grow over time. So let's say you're having this system run for years and it's an accounting system or something, and it's just a lot of data, and it doesn't make really sense to actually keep all the data as events all the time. You can actually start doing snapshots. So you could do these mementos, basically say, okay, at the end of the year, I'm going to actually say, okay, this is our baseline for the next year, right? So you now have a memento, a snapshot, which is going to be your baseline, and everything is going to be added upon on top of this. So when we store these things, so if you look at the event types, one of the things, well, very early on we discovered is that we don't really want to tie them into the C# type system. So when we store the event and we say it's this type of event, we don't tie it into the C# namespace type blah, blah, blah. Because that might, well, we're developers, we're refactoring all the time. We're moving things around. In namespaces, changing names, it wasn't actually right like that and things. So what you typically do is then just identify with something that is unique, like a GUID. So you associate a type with a GUID, a unique identifier, and you use that as the identifier for the event type instead. So an optimization you can do on the storage part is when we do these upcasts and downcasts for migrations, we can do them on the event. We don't necessarily need to do that all the time. Like when we're replaying and doing these things and actually doing the upcast and downcast, we can store the result of that. That's an optimization that we can do onto the event. So if you look at, instead of partitioning inside one database, so let's say you have a software as a service type of scenario where you have multiple customers. Instead of having one big event store for all those customers and start partitioning inside it by typically like a row level security or something like that, where you actually had to add a tenant equals, where tenant equals, blah, we can actually split it up into different databases and use that as a partitioning strategy instead. So I mentioned compensations. One of the recent discoveries is actually, instead of writing specific compensations, going in and say, oh, this happened, and that's wrong, I go and create another event type. So if you look at ledger systems, this is what they do. So they go and create a compensation for what's wrong, right? But instead of formalizing that compensation as another new event type, what you're really saying is, for the most part, there is something wrong with the data in the original event. So, well, let's compensate that. But let's not go in and just change that value. Let's actually make a compensation inside that event, right? So we go in and actually add a compensation. We actually make a record of it. So inside the event, there's kind of an event store in each event, right? Where we actually go and say, okay, that changed. And we record what changed, who changed it, and when. And that way we have full audit trail of the compensations as well, which can be very useful. And what we do, so we're building an insurance system. So what we need for this, for instance, is to be able to say, because rules change in Norway, for instance, G-beløp, anyone familiar with that? Grunnbeløp, right, for, that you use for all calculations of like your salaries levels and things like that. That changes, and it might actually be valid from a certain date. So what we have is also added to this is valid from. What we can then do is actually go and say, okay, that we can start replaying with a valid from date. And we can say, okay, we want to see the state of the system when it's valid from that date, which gives us another dimension of the whole temporal database. So that's basically what we think about compensations nowadays. And actually to that point, so what's important about this is, one of the things that we saw is when we didn't do this, is that we had to go to the developer and say, you have to create a compensating event. Not only have to do that compensating event at that object, but you also have to actually make the logic that actually does the compensation. So when you have a customer screaming down your neck saying there's a bug in the system, and you go back and say, yeah, it's going to take 3 days. Yeah, but it's just a value. It's supposed to say 35, not 36. Yeah, but my developers, they're busy with something else. That doesn't really work. So we should have tooling for this, right? We should have something that enables you to actually go and do these compensations as it happens. So public events. So if you have public events coming from another system, we want to not just rely on those events. I mentioned the outbox. So when microservice sends something out and the other microservice takes it into its inbox. But from the inbox, you want to turn that into something that is meaningful in your system, in your part of the system. So you turn that into meaningful private events and do not rely on the public events directly, right? So you're not coupled to their API directly. That means you're now autonomous. You can start replaying and do all these nice things. So you should also, when it comes to the autonomy, you should really think in the terms of that system can go away. So redaction, that scenario I said about the medical history, that's a very real scenario for our system. So when you're dealing with insurance and pension and things like this, you get medical records wrong. So you need to be able to actually go in and say, well, that should be erased from history because that's obviously insanely wrong. So having a formalized way of redacting information is very, very important for us. But again, we don't want to just go in and delete the event. We want to make a record of, well, we actually have, well, we're not going to keep the original data, but we want to make a record of the fact that we did the redaction and who did it, when it happened, point to the original event type that was redacted, but not its content. That again gives us traceability, full audit trail over the system, which is super important for our system. It might not be for yours, but for our system, auditability is key. It's the most important thing we do. So when you look at the stuff that actually, I mentioned the observers, and what they do is they translate from events to these read models, making sure that they produce the same result over time, every time, is super hard, right? Making them idempotent is actually very, very hard. So what you typically need to think about here is every observer needs to have its own read model that it owns. It can't share a read model with this other observer because who's going to win? Who's actually going to win that race? So you need to think about these things and actually isolate them completely. And they cannot, and I've said this before, you cannot rely on state from another observer because you don't know the order in which they are being processed because we're doing this in parallel. And one of the solutions to this is formalizing projections. Instead of doing this imperatively, which is super hard, let's do it declaratively. Let's declare the result we want and let an engine deal with this type of complexity. Instead of us having to deal with that type of complexity in every observer, we can just say, okay, this is what we want. Go and do it. And just make sure that the projection engine knows how to actually deal with that. And the projection engine can actually also then deal with things being out of order. It's actually possible to do. And then guarantee an idempotent result. Right. So if you do this, some opportunities actually arise. If you do this right, declaratively, and represent it in like a structure, like a JSON structure or something, all of a sudden we can start create tooling on top of it. And we can let other people, not just devs, go in and create projections. Maybe they want to project, one of the cases we actually want to project directly to Power BI. And why should we have developers do that? Instead, we're building tools for actually enabling other people in our organization to do that because they know how to do reporting. We don't. We don't know what data they want. And that might change faster than the actual application. But if we give them the right tools, we empower them to go and do this themselves. So projections also represents a developer productivity, and I will show you this afterwards, what I mean by that. It's also a hell of a lot easier to do relationships because we do have relationships in our domains. Even though we might store it as documents, there are certain relationships. We actually have children inside our documents as well. And you might actually point from one thing to the other and have a one-to-one relationship. That's also easier to do with declarative projections. Aggregate roots, that's one of the things that's mentioned a lot in that blue book that I mentioned, the domain-driven design. So basically what it's saying is that an aggregate root is responsible for the invariance of change, which is just mumbo jumbo for rules, right? It's actually, what it's responsible for doing is just making sure our system is consistent. So it's the last piece of the puzzle that says, no, you can't do this. you're not allowed to do this because we're in a certain state. So that's basically what an aggregate, of course it's a massively simplified, but that's one of the main things that it actually deals with, is look at what can be done and not to provide a consistent system. So what we see often is that we tend to use the aggregate root as one type of partitioning key to actually optimize a system. So if you look at the other side of this, when we're actually looking or observing the events, we partition based on the aggregate root it's coming from, right? And that's a good way to scale that out. But what we're seeing is that it makes it very hard to change the system, because if we change the boundaries of an aggregate root and all the previous events have been tagged with that aggregate root, we now have to, well, we can pick from a bunch of different strategies to fix that. But in effect, we would need to go back and actually change things. We would need to go back and say, okay, no, it actually belongs to this other aggregate root, because the aggregate root needs these events when we are resuming them, right? So when we get an instance of an aggregate root, it needs the events that is relevant for the aggregate root. So that makes it very hard to evolve the system. So I'm making a bold statement, not that important. So no one's throwing stuff at me. That's my opinion. I don't think it's that important, really. We can simplify the whole thing and actually take it out. Certainly you can do these things. It's a good structural pattern. It's a way to actually structure your code. But we don't necessarily need all this stuff to do what we want to do. And I kind of gave it away a little bit before at the beginning of this, because I think it's much more just about the rules. It's really much more about not enabling to get into an inconsistent state, right? So what taking that out does is actually remove friction in your system and actually breaks it into these more finite, small, digestible pieces that are just the rules. The rules can actually then have state. The state is actually projected from the events, and they are, well, you can puzzle them together as you please, right? So if you want to relate this to a command, you can start relating like specific rules to a command, one or more, and say, okay, these are the rules for me to be able to do this, and it will go and do that, and just resume state from the events and be strongly consistent and do that. You don't necessarily need an object representation for that. You can do this independently on specific rules. This is my hypothesis. So I'm challenging status quo, if you will. Whoa, that's funky. I think that's the break. Okay, so let's see this in practice a little bit. Let's start by actually looking at what events look like. Are you interested? Yes. Yes. Cool. I can see nothing. So basically what I have prepared here is a little bit of a sample. We'll also dive a little bit more into more complex scenarios, but I started off with that whole banking thing, right? So let's just keep it related to that. So if we look at something I mentioned, account opened, right? So it's basically nothing more than this, right? So it's a structure, it's a record in this case, and you can see the event type on top there, basically saying, okay, this is the unique identifier of the actual event type. So being a record, by nature, it's immutable, which is good. Events, we're not supposed to be changing events, we're actually just appending events. Could we do something about that light, by the way? I am actually totally blinded. I will send you to outer space. So, do you want romantic? No. Oh, that's worse. There we go. I can. Yeah. Okay. Okay, let's just keep it. Is it good? Yeah. Oh, okay. So that's basically one event. So, and if you look over here, we have, like I mentioned, deposit to debit account performed, very explicitly telling what it's representing as a state change in the system. And of course, it doesn't really have much an amount. And you might be asking yourself the question, so what about like identity? So there's a account ID here, right? So how do we know that? How do we actually know which account we're, first of all, opening, then performing deposits to? So if you look at, for instance, the code over here, saying, okay. So this is basically just a regular controller where we go and do these things. So if we look at the controller for actually the opening, right? You'll see that, well, so I'm showing you stuff that we have built our own event sourcing platform from scratch. So what you're seeing now is basically the API surface of that. And what we have is an event log. So you can take a dependency to an event log, and on it you have an append method. And as you can see on this API controller, we're actually getting an object in there called open debit account. On it sits the account ID. And what we're doing there on the append, the first argument that we're sending in is actually the event source ID. So that's basically the unique identifier representing that event source that will hold all these events. So the account itself is an event source. So we're going to append for that account ID. And that account ID, so one of the things that you need to, well, you need to kind of think about, when I said all about these consistency models, typically in a SQL or relational database, you might get the unique identifier from the database, like a sequence number. And you're letting the centralized thing decide what the next sequence number is. What we tend to do in these types of systems is that we actually do rely on GUIDs all the way through, meaning that we can actually create the GUIDs from the front end. So we're passing in all the way from the front end the unique identifier instead. So what this does is basically say, well, go to the event log and append for that identifier, object identifier, this event. And that's it. And we do the same thing for the other events. We have deposit, withdraw, and we do the same thing. So from these, we can now start observing. So these will now go in and actually be stored into the event store. And we can start observing these and do something and react to these changes. And I've been saying projections, either be it like manual projections or automatic. So if you look at doing this manually, so if you look at the structure of this project, we have something called read. So what I have is, for instance, an object called debit account that holds that unique identifier and the name and who owns it and the current balance of that. And what we can go and do is actually go in and basically start now with this observer, which again, you'll see here is identified with a unique identifier. And there's no interface to implement or anything. This is just by convention. And it's just basically saying that any method that looks like this, looks like that particular signature, will be called when that event occurs. So, and we don't even care what the name of that method is called. We just basically look at the signature. And there are two types of signatures supported because we, as you can see here, we only get the event here. But there's another signature where you can actually go and get more information, which will be handy. So there is something called event context, which gives you more details about the event. So when it occurred, the event source ID, and things like this, which is important. For some, well, not for all, but for instance, this scenario, that would be important. So If you look, I do have a Mongo collection going in here, so I just have that, and I can start now actually doing things to it. So the initial thinking might be, just insert now a debit account. But if you look back at replayability, we don't want to insert every time this happens into that collection. So if we go back and replay, we would now be inserting that account every time we replay. That means a lot of the same account, which wouldn't work. So what we tend to do is use upsert, and we use replays with an upsert. So for this, we will go in and do like a thing where we actually go and replace. Yes. I love it when I don't have IntelliSense. So I would go and say, okay, let's actually replace this particular ID equals, and then we actually need now the stuff that's coming in from the context, because that holds the information about the event source. So inside this, we actually look, if you look at the event context object, which of course would have been nice, well, I'm on my own, which is always nice. So I'm not going to start pretending, I'm not going to play the compiler today. So since this already failed, I'm just going to walk you through it. So what this does is, so what you would typically go and do is something like this. You would go and do it and get from the, like so. And I would create an instance of that object. And you would also have at the end here, you'd have replace options kind of thing. Can't remember exactly the name, but is upsert equals true, right? So that's just the basics of this. And if I were to now go and do like, I want to have that whole thing where I'm actually updating the balance, I would now go and do a second one of these. So I would do, okay, so deposit performed, right? And sure enough, we would have that name, deposit performed for debit account, right? And we would go and then just do pull the existing document, add the amount to the balance, and then update this, right? And of course, doing that for withdrawal would be the same thing, all right? If I could type. You get the idea. So this becomes very tedious over time. And there are better ways of doing this. So sometimes you need to do this. You need the fine, granular experience of doing this. And maybe it's more related to when, well, let's send an email when things happen, right? So maybe that's more the case, not necessarily update the current state in your system. So use them maybe for that type of scenario where the reactions thing that I talked about, the if this then that. And also here, you can also take I'll show you what we do, for instance, when we need state into these things. That is actually coming from, not from a materialized state, but actually from events itself to do decisions, right? So if we pretended IntelliSense worked and actually go to something that is working and look at the whole projections instead. So instead of doing what I just did, what if we could make that experience a little bit better? So I mentioned the whole declarative approach to this. So looking at, instead of doing that observer, what if we can represent the whole thing like this instead? So what that is saying is that it's a little bit like link in a way. We're saying from that event, we're interested in setting these properties. from this other event, I'm interested in setting, or adding in this case, adding the balance with the amount and subtracting. So it basically is much more readable and it's much more condensed and it's declarative. And we can now actually also scale this out in a very different manner. So if you look at projection engines out there, they tend to do this. They tend to have their own query language, if you will. So if you've done Kafka with Confluent, they have KQL. That's basically projections. It's projecting from streams, right? And you now get an opportunity to actually scale this out. Plus, it's much more condensed. And we can also do a lot of the decisions for you as a developer to help you reach that goal of idempotency, for instance. So that's one type of projection we have there. And if you look at other things, like, for instance, this, that holds children. So we can do complex objects as well. So if you look at the object for this, that actually, god damn. So, hello, I need my OmniSharp. So if you look at the actual object for this, you'll see that it actually just holds an enumerable of account transactions. So this just projects into that. So every child now becomes automatically just projected into this. And we have different options for how you identify the children, how you actually set up that relationship and all that. But this is a very, very simple one just to see all the transactions. So what this does is create an object where we can go and pull one document and see all the transactions going on, right? Without having to go through, zip through a index of a database. So this is, when I talk about projections, this is kind of our learning is that we want to go this way. We want to do this rather than the imperative way. So in comparison, just to be blunt, so that is the comparison. And this one doesn't do half of what that other thing did in terms of functionality, right? So let's see. What do I, so my plan went all the way, so I had this nice script and all that, so it didn't work. So now I'm just freestyling. No. Which is always nice. So one of the things that you actually do see in your system is that, well, there might be failures. So what I want to do, first of all, let's demystify a little bit. And actually, I think this is running now. There we go. So, and what we want to do is go to our bank sample, and I want to just produce a couple of events. And we do these things. So, looking at the database now, so looking at what, just to demystify the whole event store a little bit, what we actually have in it. I mentioned the event log. So the way these look like, so all the events that I put in now are basically like this. And what we're capturing is, first of all, we're capturing something called correlation ID. Because we want to be able to actually track back what happened. So anything that happens, so let's say we were producing multiple events in one go. We would then now tag them with the same correlation ID. So we can see, okay, that's the request that happened. So that represents part of us being able to see what happened together, right, in one go. So it's a good tracing tool. Causation typically would be filled with, okay, that's coming from that controller. It's that controller and that action that actually performed this. But it would be a reference to it. It wouldn't be the actual information on it. It would be a GUID, similar here, pointing to the actual reference to it. As you can see, caused by, I'm not logged in, so there's no user here, but that would be just a reference to a user. And when it happened, the event source ID, and the actual content. And you'll notice on the content that it has a 1 and an object. So every generation is actually stored here of that event. So if that event type changes, we will just upgrade it for optimization in line, kind of in the document, and put it in. Same goes for compensations. So that's an empty one, so there's not going to be anything in it, but the compensations would be here as well, right? Directly on the event. So that's kind of how that looks like. And every observer has a position in the system. So they're basically offsetting into the event log saying, where am I in the system? So, and they're independent. So they have independent offsets into the event log. And that's basically what it's saying. So remember that observer ID that we put in? That's the observer ID for that. And it's looking for offset 1. That means the next event that it wants to observe. So when we don't actually have it running, so it's actually on that because it hasn't done anything, right? So if we do something like this, and do this again, I think. And since I'm freestyling, I'm not entirely sure if, yes, it worked. So what you want to do is, because they can crash, and you want to be able to have a kind of a self-healing system and recover from those crashes. So what we do is capture this, and I realize that that's actually hard to read. So we capture information about what happened. And there's also a stack trace. And the underlying, what we call the kernel, is actually retrying all the time. And it will have a back-off strategy saying, because it's not going to retry every, like, are we there yet? Are we there yet? Are we there yet? It will actually back off. And eventually, after yay number of attempts, it will stop retrying. And what we're going to be building into our tooling is the ability to actually go in and manually start it again when the code is deployed and things like this, because now we've fixed the bug. So it's important to capture failed observers and where they failed and for what partition they failed. So let me see. I just need a little bit of a... Yes, yes. That's interesting. Yes, I've done that. I've done that. Interesting. Cool. That's me figuring things out. So I mentioned also the integration part. What we've done is we're very declarative in our approach, because declarative means we have control in the kind of the kernel part of our system. That means we can run things in parallel without the developer actually have to think about that themselves. So for us, integration, remember I talked about that whole closed loop, about comparing things and doing all that. You don't do that. You basically tell the system what you're trying to do, and the system will go and do it. So for integration, what we've done is things like this. So this is a kind of an attempt of showing, okay, we have this external Norwegian system, and we're going to map it over to our system and into something that is meaningful for us. So what we've done is create an adapter type where we actually define all the things we want to happen. So that entire drawing, that closed loop that I talked about, is actually this. First of all, we want to define the actual model that we want to use for the comparison. So that's just projections. That's the same projections as I showed. But we also want to define, well, when there are changes, what does that mean? So for this, what it actually says is, when these properties change, either one of these properties change, we want to produce that event. And that's all you need to do. And there are more complex scenarios, and it's also very extensible for what types of things that you want to do. And it's also built on top of reactive extensions. So it's basically just an observable stream. So that's defining the changes you want in your system and the events that you can see is being used here. And the last piece of the puzzle is actually basically defining, since we have a external system that actually has a shape of an object that we don't really care about, we don't want that shape, we want to kind of have our shape, this one actually says how to map that shape. And that's all you need, and what it will do is then, in the engine underneath, is do all the comparison and do all the heavy lifting for you whenever you just give it stuff. And the way you give it stuff is through this. So this is kind of a little bit of a pretend thing. It's an API that we can trigger that goes and imports this thing. And that connector will actually then take an instance of an importer that you can hand off data to. And that's the whole play. That's basically how it all fits together. Because what you can do is go for the importer for that particular mapping that you saw, those two type of objects, apply this object. And you do the, well, figure out rest. And it will produce the events accordingly. Make sense? So I'm showing this as kind of a reference of how we are doing things, and there are, remember I said just as many solutions as developers in the room, or +1, yes. So obviously there are many ways of doing this. This is how we do it. So if we look at one of the things that we have been doing as well is, where did that go? There it goes. So when you run this, for us it's been very important to actually have a good developer experience for our developers, so they can actually make sense of this. And looking at MongoDB is not necessarily a good developer experience with all those GUIDs. So making this feel a little bit nicer. And built into the whole thing is also this notion of a workbench, basically. And we're very at the beginning of this, so it's very crude at the moment, but at least you can go in and see the different types in your system. So I can go and see the different types by name. So we do associate metadata from the type, so not only the GUID, and we register them into a schema store, and the schema store is versioned. So when I click one of these, let's see, person registered, you'll see version 1. We don't have more versions. So there's one version of this event type, and these are the properties on it, and of course the types. And alongside on the types, we're also storing information like GDPR. We're storing, this property is a GDPR PII, and needs to be treated differently, and things like this on that as well. But we can also go and look at the event log. So you see the different events that I did. And we can, of course, go and look at the details of that event in a better way. And this has much to be desired. Right now, it's just a list of things. We want to, of course, put in more filters and make it much more nicer. But you can also go and see the different projections and start rewinding these, right? So if you have a projection running, we can start going in and rewinding these, which is super important. And they do also automatically rewind when so if I were to do a change on the definition of a projection, it would automatically rewind itself next time you start up. And it would also rewind and actually I can show you how that looks like actually. So let me stop this and instead run this. I'm not full. Oh. And since this now have projections, we'll see more projections in that list. That's a hard claim, but I'm hoping. Yes. And they just showed up here. So we'll see, actually we have now projections that has already run. So that debit account thing, the transaction thing. So if you look at the database now, we will actually see more stuff here. And we're projecting down to Mongo, and we'll see here, yeah, balance 42. And if I were to now go and rewind one of these, so let's rewind that, you'll see in the database something happen. It actually keeps a copy of that old collection to be able to just quickly roll back. Right? So we keep a copy of that so we can actually roll back instantly if there is a problem. The projection was wrong or a bug in the system. So that's one of the things that this actually does for you. Yes, the event store, there is a shared concept. So I said about the partitioning, every microservice and every tenant of the system has its own event store, basically. But there are shared things, like the shape of projections, well, how they look like. The event schema is shared because that is your system, right? That doesn't change between the different tenants. So we keep that as one thing. So if you look at, for instance, the projection definitions, that's actually a, you can see it, how it actually looks like. So let me see that, let me find the one. So the debit count, and it says that's the event type actually, right, the GUID. So it's saying, okay, from that, I'm interested in these properties. So that's the definition of the projection actually. So that means we can now go and do tooling quite easily. We can create tooling where anyone can go and create these projections without having to, well, involve a developer, which is quite nice. And you look at the same for event. That's actually JSON schema. So what we've done is basically, okay, let me see. It's just a JSON schema holding all the information about every event type. And the nice thing about JSON schema, it's very extensible. As you can see with the compliance, we do add metadata to it. So we're having compliance into this and saying, okay, it's this type of metadata, and you can actually tag things with details. So for instance, for PII, you can tag it with the reason for collecting this type of PII, for instance. And it will show up in this schema, and we're using that internally into the engine to apply compliance as we go. So with that in mind, so if you look at one of the things that you saw here is there's this GDPR thing as part of the whole thing. So in this, this is where we can actually go and see the different PII. So I haven't actually registered anything yet, and I haven't actually created a key yet even. So what I can do is go back to here, and I want to just grab a GUID for my sample. So I want to go and create a key for this particular person. So nothing happened here. There's nothing, and that's by design, because actually what's going on is we have now, we're using Mongo right now, but we're going to switch this to Azure Key Vault. So this is the key that I just created. It's a public-private key. And one of the benefits, so one of the things that we had a design choice, we don't want the keys to leak. So even though we're going to rotate the keys, we definitely don't want these keys to just be available to everyone. So we don't want them in the code. We don't want them to be accessible to the developer even. So this is kind of a zero, absolutely zero trust environment. So the private key is only inside this container that runs the kernel that we talk about. which is only accessible through a client API. And the client API does not expose this. So the private key is only accessible there, and the only place we can actually decrypt things is inside the kernel. That way we won't run the risk of leaking this. Well, it's less of a risk, if you mean, right? So from this, we can now go and, let's say, use this API now to register a particular person. I'm going to register myself. And what happens is that, okay, I now have this person registered. And if you look into the event log for that now, you'll see that we now have a new thing where everything is encrypted. And all I need to do now is just delete the key. And that person is, well, we don't have to delete the event, but I cannot read this data. So the data is safe. But I can use this internally, so I can use this to, if you look at MongoDB, for instance, MongoDB supports the same type of mechanism. So we can project encrypted with MongoDB and use custom approaches to actually decrypt it. So we can hook up personal certificates in MongoDB to decrypt it when we need to see it. We don't even have to project it unencrypted. So if we then go and, so another thing that I can do is I can add, for our system, we basically said there are some things that are formalized, like the personal information containing address and things like this. That's formalized events that we have. And there are things that might be very custom for each microservice, where you want to go in and just basically like a key value store say, okay, I want you to add this personal information to that person. And we have that capability as well. So we can go and just run something like this. And if you go here, you'll see the different details on it. So it's nothing fancy or anything. It's just showing a little bit how we're thinking about this. So the way we've done this when it comes to how we actually look at how do you classify PII. So you don't want to necessarily go all over the place and do this. So what we have done is basically give you a couple of constructs as a developer. So we have this base class of something called, well, we have this concept of concept. The thing of formalizing domain concepts, where we actually, instead of using like strings and primitives and things like this, we actually create types that represent what they are. So like social security number is a type, it's not just a string. And we've also gone all the way in and said, okay, we do have very specific types of concepts, like a PII concept. And what the system will then do cross-cuttingly, automatically for you, is anything that is of this type will just encrypt it for you all the way through and decrypt it when needed. So we use this on the events, and we use it on the read models, and it will just do that for you. So you as a developer, it's totally transparent for you. All you need to do is this. Or you can use the attribute. We also have an attribute called PII. So as long as you do that, you're good to go. And this is a good model, so I would highly recommend, if you're looking at scaling things with your developers, look at something that can be, anything that is cross-cuttingly possible to apply, go do it. So that's what we basically do for, all this information actually. So if you look at first name, right? And all I need to do, if we look at, it's kind of cool, the kernel is dog fooding itself. So the kernel that we have running as a container actually is using itself to do all these things. So what it does is it has formalized events. It has all these GDPR events, a person registered. And as you can see, it's just using these concepts. First name, last name, and will automatically then just do that for you. So that's the GDPR part. And I wanted to show a little bit more complex things. So I work for Axio. I mentioned I do kind of it's an insurance tech company. And what we're doing is basically build the entire platform from scratch, meaning this entire event sourcing stuff, but also the deployments and all that stuff. So what we've done is create a management tool for deploying things into the cloud. And what we're doing is using Pulumi to automate everything. And basically this is an event-sourced application on itself that we build to make it easier for us to, well, basically set up applications and microservices in it. So it has a vastly more complex scenario than the simple banking example that's part of our sample thing. So what it does is it has reactions, it has, well, not at the moment, but it will have rules and things like this, because you cannot deploy the same microservice twice and things like this, right? So if we start with the reaction part, and what it does, it needs state. It needs to be able to actually do state that is not persisted in a regular database, but it's leveraging the state from the event store directly. And it's doing this by using the projections, basically. So what we have is something called a passive projection. And what that means is it's a projection we're running ad hoc. We don't want it to be actively running all the time when things change, because we're not actually persisting the result. We don't care about persisting the result. We want the result when we want to get an instance from it. So, but it's defined in the same way. It has the same kind of setup, and it's definitely just the same type of projection. And this is a much more complex object, as you can see, with children on it and whatnot. So what we do is inside one of these, I lose my focus, sorry. What we actually have is this one. And it actually is relying on a few different of these projections to kind of make decisions. And what it does, it is basically just an observer. So if you look at this, it's observing things and has different events that it's observing. So application created, okay, we want to, and this is the whole magic sauce. It's basically like a repository, if you will. So we go and say, get me an instance of application with that ID. So the event source ID we have here. And it will go and actually replay those events with the projection and give us the state right there and then. So that's how kind of we've solved this whole entire thing. And from this, so there's a lot of Pulumi stuff that we're doing here to automate the cloud stuff. So we're basically handing it off to, well, some templates that we have created for creating environments. But that's kind of the gist of these things. And if you look at what we're going to do with rules, we haven't implemented the details on the rule stuff, but it's definitely going down this path. So when we have a business rule that needs state, it would be doing something similar. It would be relying on like a passive projection and just get the state, project it out to whatever it needs to check, and then run the rule on that state, right? And use something like Fluent validation on top of it. And that's it. So just regular, however you would do ASP.NET validation, right? All you need is just the state. And we can get that by using projections. I think, yes. Is there anything interesting here to look at? No. A lot more events. I think you're getting the picture, maybe? Yeah. Yep. That's very good. because then we can do something else. We can go back here and look at this. And yes, please. So just quick on how we built this. I realize we're going from dark to very bright. Sorry about that. So what we've done is, at the core of this, we built everything on top of Microsoft Orleans. So it's an actor-based system. So very, very, very simplified view of this whole thing. But basically what we have is that event log is a grain, is an actor in this system. And we can go and append stuff to it. And what it does is it puts whatever we're appending. The grain itself actually holds state, and the state is the sequence number. So it guarantees a unique sequence number, or the actual global sequence number for the event log inside the grain. And Orleans is a distributed system. It's an actor model-based system and clustered. So it will guarantee something like the sequence number across the cluster for that grain. So we go and append, and all it does is basically go and set the right sequence number for the object or the event that we're appending, setting the metadata, putting it out on a stream. So Orleans has this concept of streams. And what we do is we have a formalized event log stream, and we've implemented a stream provider that is basically taking whatever is being put on the stream and persisting it. And that persistent can be anything. In our case, it's Mongo, but it could be anything, right? And we're very agnostic about where it is right now. We can change that if we want to. And another type of grain or actor is an observer. And there's actually a more formalized version of that, which is the partitioned observer as well. And it basically looks at the same stream, because that stream is also useful for actually observing. So we used it for persistence, and we also use it for observations, and then all the way up to the client. So you can find all this. I'm going to speed up a little bit. I got a note. So you can find all this on GitHub. We're doing everything open source. So if you find this interesting, just go and look at it. So when should you do this? All the time, every time. It's the magic bullet, silver bullet? No. You need to start asking questions, of course. You should ask yourself, are we ready to do this, right? Do we have an organization that is thinking in events or want to think in events and is ready for actually doing this? I would start there. Will it add anything to our system? So I'm not saying, I have a kind of a natural inclination of doing this because I like doing this. So I would pick this every time, but you need to ask yourself, does it make sense for our system, right? So you need to do that. Do we have the know-how? Do we have the tools to actually do this? And I'll get back to the tools a little bit. And don't do it because it's cool. It is certainly cool, but don't do it because of that. That's just bad morality. So what kind of scenarios would this fit? But it's not just the complex scenarios, but it's definitely not your website, right? So you're not, it's somewhere in between, and definitely the complex scenarios as well. As I said, I have a natural inclination of doing this way. This is how I like. I would not, I hate doing it in another way. So to me, I would probably become a farmer or something if I had to go back. Because I love this, I absolutely love this. But it makes sense if you have all the right tools and you know how to do it, go for it. And as I mentioned, do not mix what is the source of truth in your system. It's either event sourcing or CRUD. So where to start? Well, there are a bunch of different things out there. And I would say probably the most popular, or at least natural thing to go to in the .NET space is Event Store. As it says in the name, it's an event store. So this is a company that was founded by Greg Young back in the day, one of the, I would say, pushers of event sourcing back in the day, right? So, but there are other options as well. MartinDB is definitely one, and an event store looks really promising. And there's a TypeScript implementation which is really, really cool. I like their API surface. It's based on GraphQL called Booster. So that's if you're doing event stores. These are some of your options. There are much more. And there's actually quite a few out there, and you'll find a bunch. But these are at least to a certain maturity level where it's actually usable. Right? And cool thing about something like Event Store and Booster is that it's platform as a service. You can just go and sign up. Right? You don't need to, all the hassle of doing it yourself. So there are also more mature platforms, if you will, out there. And if you look at something that is more packaged, giving you more an end-to-end, not just the event store, Booster is one of these. So it gives you a complete framework for working, like an application framework for this. And there's also something called Vlingo, Zoom, which comes with a suite of tools. And especially when you're talking about process and how to actually model your system, Vlingo Zoom is very interesting. Axonic is another one, which is very focused on the whole microservice thing and CKRS and all these things, and domain-driven as well. So general purpose things, which is, you can do all these things with these things if you want. So looking at Kafka, and I mentioned Confluent as a projection engine, a very common go-to in event sourcing, right? But they're very general purpose, as I said. And so Kafka is not by default holding events, but you can set up a retention policy to let it keep events forever if you want to. So that's one thing. And putting things like Spark or Hadoop on top of it, wrong links, I see. I'm bad at links. But these types of technologies on top can do projections, right, at a high scale. So it really depends on your scenario and what type of data you're looking at. What I've been talking about today is mostly about typical line of business applications, which does not have 1 million events a second, but more like 1 million events the next 10 years, maybe, right? So, of course, if you're inclined to use Azure stuff from Microsoft, you'll find things like this, Event Hub. I'm not saying Stream Analytics is the perfect projection engine because it's built for a different purpose, but it is an example of a projection engine that takes real-time data and projects it to different sinks. Right. When it comes to process, which can be very important, so if you want to really go into event sourcing, you should probably think about how do we actually model things, how do we actually understand how to get the right events. And there are a couple of ways of doing that. One is event storming, and another is event modeling. And personally, I'm leaning towards event modeling because it's much more than just the events. It's actually a lot more, and it's a kind of an iteration, in my opinion, on top of event storming. I think I'm out of time. Thank you.